Good afternoon. Thank you very much for coming to the HIMA workshop entitled It Takes Two to Tango. My name's Buddy Kreef, and I'm with HIMA, as you might have already guessed. Thanks again for attending. Welcome to our session. HIMA in 2018 is celebrating its 110th anniversary. For almost the last 50 years, our focus has been on safety. We are totally a safety company. That's what we do. It's all we do. We believe in and we're dedicated to robust, independent safety systems. Our goal collectively in the room, we assume, is safe operation. And safe operation, of course, is based on functional safety. But there are a number of things that we have to achieve if we're going to achieve safe operation. We have to, an absence of failures. We have to have a control of failures or a way to deal with failures when they do occur. We need a reliability evaluation. And then what we would propose to you is we also need security. We can't be safe if we're not secure. And so when we say it takes two to tango, what we're saying is that safety and security have to go hand in hand, even though they're derived differently. So I'm just going to introduce Peter Sieber. I should have said on the first slide, I'm not Peter Sieber. I'm going to introduce Peter Sieber. Peter is active on IEC 61508 and IEC 62443 committees. He's the Vice President of Norms and Standards for HIMA, and he's also the Vice President and General Manager of HIMA China. So if you will, I'll turn it over to Mr. Sieber.
Thank you, Buddy. Good afternoon, ladies and gentlemen, or probably I should say, Cao Hen Hao. Ni Shanti Hen Hao Ma? Okay, that's all of my Chinese, and if you won't mind, I would like to continue in English. If somebody would have asked me 2 years ago whether I start talking about how to dance tango, I probably would not have believed that this is going to happen, but nevertheless I appreciate the possibility here to talk to you on our understanding what means dancing tango in view of correlation between functional safety and security. Well, I would like to start my presentation with a little bit of an example. Based on my job, I have to travel a lot. So last year I did something like 230,000 air miles. And well, what happened to me was at a dedicated moment in time while the aircraft I was sitting in was airborne, all of a sudden the video entertainment stopped. And instead of the video entertainment, I saw the screen that you can see here. So I would not call myself an IT expert, but I recognize that obviously something is rebooting at the aircraft. And if this happens when the plane is airborne, you're about 30,000 feet above the ground. Of course, you may raise the question, how would you feel? Would you be worried? Would the plane would be in trouble? Well, in my experience here, the plane, as you can see, I'm still here, so the plane was not in trouble too much. At least not based on this reboot of the video entertainment system. At the end of the day, what is important here is that this is a good example for an alignment between functional safety on one hand side, because safe operation of the aircraft, of the machinery control of the aircraft, of the navigation systems is very important. On the other hand side, also security is important, and obviously the designers of this aircraft at least did some precautions, making sure that certain interactions do not negatively impair the performance of the aircraft. Having this said, if we are looking at the correlation between functional safety on one hand side and security on the other hand side, it is important from our point of view to understand that functional safety and security are focusing on totally different aspects. Even though there is an interaction between functional safety and security, as Buddy Kreef just said, there hardly will be safety without security. So even though there is an interaction, there is no direct correlation between security and safety. This implies that safety and security also do not have an automated kind of correlation between the recommendations to be fulfilled. And last but not least, it is important to understand that aligning functional safety and security is requiring a specific strategy to be implemented. And this has been recognized also on the level of the International Electrotechnical Committee. So about 2 years ago, a working group was established thinking about how to align both the recommendations of IEC 61508, the basic standard for functional safety, and the IEC 62443, the basic standard for security for automation systems. And as a result of this undertakings, a technical report named IEC TR 63069 is actually still under preparation. We published the first version a few months ago, and I think the final release can be expected within the next 2 or 3 months. And yeah, we were about 20 experts globally who discussed the subject, and we made quite some progress. It only took us 18 months to agree on what we call the guiding principles on how to apply safety and security simultaneously. So principle number 1 is the protection of the safety function. That means we say that the safety function or the effectiveness of the safety functions may not be impaired by security aspects, right? That means if you are looking at the the safety function designed to maintain SIL 3, this means that a dangerous failure is accepted to take place once 1,000 years. This is why we're calling it SIL 3, right? And protection of the safety function here means that the correlated or the related security settlements need to be good enough in order to maintain this performance. Second principle is the compatibility of the implementations. That means it needs to be ensured that the security installation does not negatively interfere with the safety installation and vice versa. And the third principle is the protection of the security countermeasures. That means while operating your safety installation, it needs to be ensured that no operational activity attributed to the safety system may negatively compromise the effectiveness of the security implementations. What does it mean? Well, if you, for instance, have to put a notebook into your system in order to carry out recurring testing, and you hand carry this notebook around all firewalls installed, you may think about how to make sure that this notebook is not having software on board that you may not want to see in your safety installation. So these are the 3 so-called guiding principles, and along these guiding principles, we decided or we defined a strategy on how to align functional safety and security. Core of all our developments and core of all our thoughts is the safety and security risk management. If looking at risk management, typically in the area of functional safety, we are looking at human protection, at environmental protection, and to a certain extent at asset protection. Looking at the security risk management, we also need to look at information protection and also an aspect called business continuation that seems to be a bit new when talking about functional safety. The correlation of these 5 aspects is providing the unmitigated risk. This unmitigated risk then is taken into the safety hazard and risk analysis that is governed by the IEC 61508, where you are defining your safety risk mitigation measures. In parallel, the same unmitigated risk is put forward to the security hazard and risk analysis that is governed by the IEC 62443. So what we see here in essence are 2 parallel processes One is looking at the security risk mitigation, the other one is looking after the safety risk mitigation. And the key question now is how to align both. And the idea we developed is that we say, okay, at a dedicated moment in time, the safety experts are required to describe the usage they are looking for in terms of the application of the safety installation. This description details have to go into the security risk mitigation strategy, and then you can define what we call the security environment. The meaning of that I'll come back to in a moment. Based on the alignment of the three guiding principles mentioned, then the final safety design is decided on, and an interactive process needs to be implemented, making sure that safety and security can be aligned in an appropriate way. So this is a way how the risk management tasks are able to be implemented so that both tasks can be synchronized. Talking about the security environment for functional safety, you may understand this as two domains, the safety domain on one hand side, the security domain on the other hand side, and between both domains there is a certain overlap. And in this overlapping area, you have to, on one hand side, define the protection of the perimeters of the safety domain. That means you have to decide on all the measures required to protect the borders of the safety installation. You have to think about how to protect the interactions between the different elements inside the safety domain. And last but not least, you have to think about the protection of every individual device you operate inside the safety domain. This is the idea we developed, saying based on this strategy, we can create an environment that allows the alignment of functional safety on one hand side and security on the other hand side. Now, having this said, one of the key challenges is here that we do not only need to create a design that is sufficiently protected, we also have to make sure that during the entire life cycle we can maintain this protection. And we're saying here, our Tango lasts for longer. That means we need to think about the coordination of the safety and the security life cycles. And one of the big challenges here is that if we are looking at the safety life cycle, we're typically talking about updates and reviews in yearly time frame. Depending on your application, you will review your safety installation once a year, once every 2 years, probably even once every 3 years. The focus you have is on malfunctions. That means you look at your own installation, you try to figure out, is the reliability of your equipment on a sufficient level? And it is important that you're looking at your own operational experiences. On the other hand side, we have the security life cycle, where we are looking at cycle times which are, well, weeks, probably days. The focus on the security side is not on malfunctions, but typically is on vulnerabilities. And from our definitions, a vulnerability is not a malfunction, because typically vulnerabilities are built in. Probably they are built in on purpose even. And what also is important, that if we are looking at the experiences when reviewing the security life cycle, we are not looking at operational experiences, but we are looking at experiences made in the entire community. That means the process of gathering information, if you compare safety and security, are totally different. So in order to make sure that the life cycles can be coordinated efficiently, also the security environment is the mean which we implement in order to get this coordination done. Because the definition, for instance, of the protection of the perimeters also allow you to decide on a design that may be sufficiently resilient so that you do not need to patch your safety system once a week. Now, the question might be, after all this theoretical thoughts, what did we do from a technology point of view in order to create an implementation that is maintaining all these aspects? And what we do already since at least 2 decades is we are looking after aspects when developing our products that today are called security. We started with this already in the early 90s, even though those days the term security was not even known. But we came to this point because our entire development processes, as we are 100% focused on functional safety, always was driven based on fault tree analysis and based on evaluations on potential faults. And when executing those, of course, we got across the subject that potential vulnerabilities are a fault or having an impact on fault analysis. Having this said, already in the 90s of last century, we came to the conclusion that, of course, there is the possibility to buy certain software elements from the market and to use libraries, to use third-party software elements. But we came to the conclusion, after doing some exercises there, that the quality of these libraries is way lower than the quality we are looking at. So that means if we are looking at failure rates of our software implementation, we are actually working on the same level the aeronautics industry is at. And based on that, we took the decision already back in '95 to say we will not use third-party software on our automation platform. We will do the entire stuff our own. And this is something we do till today. That means till today we have the situation that all of our software is manufactured and developed by our own. This is an aspect that allows us to drastically drive the resilience of our software products, because if you use library elements, the big issue is that you do not only have the function you want to have, you typically also get functions you don't need to have. And the combination of all these functions is something that is relatively hard to be handled. So in our case, what we do is we have in our core the self-developed software that is totally focused on automation. That is also one of our key principles. That means if you look at the software in our controllers, this is just control software. There is no integrated color TV. There is no integrated email server. There is no integrated web server, because we believe that for a safety system, you do not necessarily need this functionality. And everything you do not need, you do not necessarily need to implement, because all these things are also potential root causes of failures. Well, nevertheless, the world is not ending at the I/O terminals of our products. So since quite a while already, we are thinking about how to establish communication, how to do this in a resilient fashion. Our products are equipped with interfaces allowing to communicate to the outer world. And what we do is, at the end of the day, that we are maintaining what we call the HIMA Security Safety Core. That means around our products, in which way you're configuring them, we have a core, we have firewalls, we have protective measures, making sure that the designed functionality of our products can be maintained even under the influence of potential security-related attacks. This includes the usage of field devices, assuming that you may use intelligent field devices that may be capable of communicating with the outer world. I will come back to that in a few minutes. The automation products we serve, in fact, are only part of the overall portfolio, because of course we need to have engineering stations, we need to have MMI, we need to have certain other functionalities. And in order to maintain these functionalities on a secure, sufficiently secure level, we created what we call the HIMA Security Environment for Functional Safety. In this security environment, we on one hand side establish additional means of protection. That means there's a possibility to block unwanted changes to the software of the automation systems by means of hardware. That means you have the possibility to not be depending on password protection or something like this. You have the possibility to use means of hardware, that means in this term digital inputs, to block unwanted changes from the safety system. Of course, part of this security environment also are the engineering stations. We operate our engineering software on public domain operating systems, even though when doing the development of the engineering stations, we did an extensive risk analysis. And even though we are using a standard operating system, we do not, or we minimize the usage of the resources of this operating system. So for instance, things like database accesses that are required to run the engineering software are not realized using standard database functionalities, but we reprogrammed all this completely so that we can say today, even though the engineering software is operated on a standard PC, it does not require any specific functionalities that the operating system of such standard PC is getting along with. Communication is an important aspect. In order to maintain that, we developed our own OPC servers. That means we have our own servers maintaining OPC on the external side, maintaining an internal Ethernet protocol stack on the internal side so that we can use standard communication mechanisms, but can use them in a secure fashion. I'll come back to that in a few minutes. Of course, this security environment can be spent across one dedicated controller, but it also can be spent across a complete installation. You can add multiple controllers of the same type, but also of all different product families we host to the same security environment. You can have one homogeneous security settlement for the entire installation you may operate. MMI also is an important subject. We see quite frequently recommendations that things like maintenance override switches, operator override switches, and this kind of things may be requested to be operated. Of course, this can be done via the DCS, but we see also quite some recommendations to have dedicated MMIs for that. And in order to comply with that, we are providing solutions here where we implement third-party MMI software packages, but operate them inside the security environment we provide to our customers so that even the MMIs can be operated in the same secure fashion. Typically, around the security zone hosting the safety system, the plant security zone is established where you find all other devices of your automation installation. Now, in fact, there are two more interfaces required. One to serve the communication between the the information domain of the DCS and the safety system. This can be done using the OPC functionality, plus there is a possibility to utilize the communication with the DCS automation domain that is real-time capable. What we typically use here are protocols like Modbus TCP. You may question why Modbus TCP? Well, the answer is relatively easy. Modbus TCP because it's recognized as a reliable protocol as per IEC 61508-3. Okay. As said before, norms and standards are very important to us, and we try our utmost in order to stick to the international norms and standard stipulations when doing the setup. You may now question, well, how does all this relate to the existing international standards. And if we are looking at IEC 62443, despite of all discussions we have, IEC 62443 is called for something they call zones and conduits. That means IEC actually is calling for a dedicated hierarchical concept of different areas of security to be implemented at the overall automation installation. What also is important, IEC 62443 is defining something called essential functions. And part of the essential functions as per IEC 62443 are the safety functions. So that means if you strictly follow the recommendations of IEC 62443, you will come up with a situation that is close or identical to that here, where you have the essential functions in one core security area. You have the general purpose automation function. On the next level, you have the HMI, one level at top, and you have things like the MES, the local office IT, but also virtual plant installation, one level atop that. So what we are implementing here in terms of security concept for our products and our solutions is fully in line with the specifications as per IEC 62443. Well, in the following, I would like to walk you through a couple of use cases because we quite frequently get questions saying, well, how do you do that? How do you handle certain things? And one of the things we are asked for quite often is, how do you do modifications? Because at a dedicated moment in time, you can, irrespectively how stringently you secure your installation, you will need to change it. You need to apply changes. Well, and when doing so, this process probably is one solution for that. You may establish a connection between the engineering station and the outer world. But if you're doing so, you have to keep in mind, you open a window, if not even a door. And I think just recent developments we saw indicating that this door really is existing, and there are more than enough people around who are willing to use this door. From our point of view, the situation is such, typically such updates and modifications are taking place, well, once a year, twice a year, probably 3 times a year. And the question might be, is it really reasonable to accept such a backdoor which you only want to use 2 or 3 times a year even? And our answer to that is, no, we do not believe that this is a reasonable strategy. So from this point of view, our suggestion is to use portable memories and apply a dedicated strategy and a dedicated procedure, making sure that these portable memories do not have functionalities on board they should not have. There are more than enough strategies where you can test this kind of memories for their content. And from our point of view, this is a procedure that is bundled to a much lesser risk compared to having a continuous network connection. Another aspect we also get across quite frequently is the question, do you really need to have a separate engineering stations? Isn't it more reasonable to connect different stations on one machine? Couldn't we use virtualization in order to bring all the things together? And well, of course we can. The question just is, what are the consequences? Because in the standard setup where we have separated engineering workstations, we have the strong protection around the security environment for functional safety. In the very moment we are moving the engineering station, what happens is we again create a backdoor. And the question is, are we able to keep control of this backdoor? And yes, of course we can. The only thing we need to do is we need to create a perimeter protection around the entire plant, which is as strong as the protection level of the safety system. The question is, can this be done? Of course it can. The question just is, are you ready to pay for it? So at the end of the day, all this also has a commercial impact. So from our point of view, technology-wise, we can have this unification of different stations, but from a usability point of view, we do not believe that this is the most effective path forward. Another important aspect is you may think about separation of the safety system, and you may say, okay, let's keep the entire stuff completely isolated from the entire rest. This will cure all potential problems. Now, honestly speaking, of course, this is the absolute cure. On the other hand side, of course, information transfer and being knowledgeable about what's going on in your plants also is important. And I personally firmly believe that an adequate transfer of information is helping to maintain safety. Because not all cases that may be safety critical at the end of the day can be completely handled by the automation system autonomously. It is always important to make sure that the operating people, that the operating staff is getting adequately informed. Now, how can we do that? In our concept, what we do is we use the OPC server to communicate all relevant data from the security environment from one or multiple controllers using OPC technology to the outer world. And the way around we are doing that means that we have the first firewall outside the OPC server. We have the OPC server. We have a second firewall inside our products. And we have the combination of communication processor and gateway, which is, let's say, this combination here, this firewall, the OPC server, the firewall at the entrance of the system, is a demilitarized zone. If you use two different interfaces at the level of the OPC server. And we have a second demilitarized zone made up by the firewall here, the communication processor of the system, and a gateway that is hindering the communication processor to transmit any kind of unreasonable data to the CPU. So that in essence, talking about IT, we have a combination of two demilitarized zones that needs to be bridged before somebody may be able to enter any unreasonable data to one of our applications. And from our point of view, this is a level of protection that, as far as we are concerned, so far did not be successfully offended. I have to be a bit careful because I don't want to overcommit here, because you never know what's going on tomorrow, but from today's perspective, we feel safe with this settlement. So based on that, we have the possibility to communicate, to make all status information, all diagnostic information, all the things you want to have available to any kind of DCS using open standard communication. If you are talking about real-time data, as said before, we are using a little bit a different root cause, using Modbus TCP instead of OPC. This is just for timing constraints. But what we do here is we have a bunch of different safety precautions, starting with communication partner whitelisting. That means we configure what are the addresses, what are the names of the communication partners, and only those who are configured are allowed to talk to the safety system. The safety system will on one hand side ignore all non-configured communication attempts and will alarm these attempts so that you can have the possibility to check whether everything is okay in this communication link or not. Another important aspect from our point of view is hard technology. You may remember I touched this subject a few minutes ago. So in looking at hard, one of the possibilities is that you say, okay, we take our hard multiplexer, we connect this hard multiplexer to an external asset management system, and then we can execute all the required functionalities. In principle, this is correct. But you have to make sure, or you have to have awareness of that if you do it this way around, the field devices attributed to the safety system will not be part of the security zone of the safety system anymore. That means you either may need to move the asset management system somehow into the security zone of the safety system, or you have to think about an alternative solution. The alternative solution we provide is that we say our products are able to talk hard to its field devices, and the hard communication can be brought forwards using the OPC server, either to our own HMI, or, if wanted, also to the engineering or maintenance station or asset management system of the DCS using hard over OPC. Again, we are using an open standard communication protocol enabling all the related information from our field instruments or from the field instruments attached to the safety system for the outer world. This is a short overview on the sorts we made. And if you won't mind, I easily can talk another 2 hours about this subject matters and the related things. But I'm afraid our workshop time here is a little bit limited. Nevertheless, what is very important to us always is figuring out what our clients are thinking about what we are doing. And the generic, or to summarize, the feedback we receive from our clients is that the most of them are pretty happy with us, not being focused on functional safety only, but also providing safety solutions that are maintaining and that are considering the security constraints as well, so that we can maintain safe, secure installations for our clients. Finally, already quite a while ago, Albert Einstein said that the world is a dangerous place, but mainly because of the people who are not willing to do anything against it, not because those who are evil. So from our point of view, let's go out and do something, because the most of the things are no rocket science. The most of the things are pretty easy functionalities, are pretty easy architectural constraints to be looked at and to be considered. Question might be, what can we do for you? And here we have an overview on services and assessments we are providing to our clients, helping our clients to understand where they stand with their installation in terms of compliance with IEC 61508 and 62443, but also providing things like awareness training, because we learned that lots of security sorts starting with awareness. As long as the people who are in charge with handling the installation at site are not aware of that security is something they need to look at, you cannot expect security to be maintained. It's a little bit the same like with functional safety. If no safety awareness is with the people, then better do not expect too much willingness to follow. All in all, even though HIMA is following a strategy since many, many years now where we say safety systems have to be separated pieces of equipment, we need to make sure that we do not use common components either on the hardware nor on the software level. We are not following a strategy like we have to build walls and we have to be hidden behind the walls. We are ready for what is called the digital transformation. We are able to provide safe and secure implementations that may allow you to operate both a separated safety system that does not have common cause failures with the rest of the automation installation, but that can be combined in a secure way, that can be handle data transfer between the basic process control functionalities and the safety system based on the utilization of open standards. Thank you very much.